Okay, let's look at the proper rational functions, okay, which is actually you have the degree of the p plus the degree of the q, and under the case of q, x cannot be factors. When you have this type of integrations, proper rational functions, you come across two cases. So the first case is when you have the x, you only have the x square and you only have the constant. You just have two items at the quadratic. Okay, so we just have the x square and you have the constant, just like this example. So when you have things like that, okay, so you might come across the first one, that is at the top you will see an linear equations at the top, or you have an x. You have an x at the top. Okay, so what you have to do is when you have this type of case, you will have the answer in terms of logarithm, and it means that you're going to apply this formula. Okay, that is the integrations of f prime over f. Okay, if you have the second case, that is you only have the value, you only have the constant at the top, not the x. Okay, the x will give you the answer in terms of logarithm, but if you have the number at the top, you will have the answer in terms of tangent inverse, and tangent inverse you're going to use this formula to obtain it. Then we go for the second case that you might come across. Okay, the second case is you will have the quadratic that is in terms of three items. You have three items in the quadratics. Okay, so and this quadratic is cannot be fractal, and now it's actually in this general form. You have a general form of this quadratic, and you have three items. You have x squared, you have x, and you have constant. So when you have this type of the integrations, the functions for you to integrate, so what you have to do is you have to use the step of converting the square, and then you have to do some substitutions, and by using the substitutions, we will obtain an integrations, okay, that is in terms of u. Initially we have in terms of the x, okay, we have the integration with respect to x. Now we have the integration with respect to u. Then from this integration with respect to u, we're going to separate it into two integrations. The first integrations, you will have the u at the top, and the second integrations, you only have the number at the top. For the first integrations, you will have the answer in terms of logarithm, and for the second answer, you will have the second integration, you have the answer in terms of tangent inverse. So you're going to apply this formula. Okay, look at this example. Okay, so your example is actually in terms of this one. So it means that your answer actually will in terms of tangent inverse. Okay, and if the answer is in terms of tangent inverse, you're going to apply this formula. Okay, now how to apply this formula? If you observe this formula in front of the x, in front of the x square is the coefficients of the coefficient is actually equal to 1. So what we have here is we have 4. So you try to manipulate this equation such that you can use that formula. So what you have to do is you have to factor out the 4 from the quadratic. So if you factor out the 4 from the quadratic, at the bottom you will have the x squared. And okay, how about the 9? The 9, you have 9 over 4. Okay, and we pull out the 16 over 4, and we will have 1 over x squared plus 9 over 4. Okay, dx. Okay, so now let's just compare to what we have here. So supposedly we should have something in terms of a square. Okay, so you observe the 9 over 4. So the 9 over 4 is actually, you can write it in terms of the square, so that is 3 over 2, right? Okay, so let's just go for the next line. So 16 over 4, that is give you 4, and the 9 over 4, you can write it as 3 over 2 squared. Now, you are already in this form, x squared plus a squared. So now that is the time you're going to apply this formula. That formula says that your answer will be in terms of this. Okay, so then, okay, you will have a 4 at the front. Then we're going to apply a formula. The formula says that you will have 1 over a first, 1 over a. So what is your a? Your a is 3 over 2. So you will have 1 over 3 over 2. And we have the tangent inverse here. So we have tangent inverse, and we have the x over a. Your a is 3 over 2. And then we have plus c here. Okay, let's simplify this line. So if you simplify this line, so basically we have that is 2 over 3, and this is tangent inverse, and this is 2x over 3. And simplify some more, we have the answer of a over 3 tangent inverse 2x plus 3 plus c. Okay, look at this example. So in this example, you can apply this formula. Okay, so we have got two formula on the screen. So the first step that to solve these questions is, see, we're going to factor out the 4 from the quadratic, okay, at the denominator. So you factor out the quadratic. So you will have 4 at here. So this is x squared, and it's 9 over 4. And this is actually your dx, right? Okay, so once you have this one, okay, we're going to take out the over 4. Okay, we're going to take out the over 4. Okay, so let's just take out the over 4. When you take out the over 4, so you will have 1 over 4 in front of the integrations. Now you're already in this form, so let's just try to manipulate it just as you can use the formula. Okay, so your answer will be in terms of log and in terms of tangent inverse. Okay, how to manipulate it? That is very simple. So you split this integration into two integrations. So both of them will have the 1 over 4 in front. So we will have 1 over 4 in front. So this is actually 2x. And this x squared plus 9 over 4 dx. And we have 1 over 4 again. We have the integration. This is 9 over x squared plus 9 over 4. And now let's just compare with whatever that we have. Okay, if you look at the first item, if you look at the first integrations, what we have here is actually we have that is in terms of the form of this one, right? So you have this form. When you have this form, that is a time that you can apply this formula. That is this. That is the f prime over f. Okay, you integrate them is actually equal to ln f. Okay, so you look at whatever that we have here, and this is basically our f, and this is basically our f prime. So what is the answer of this? Okay, the answer of this is actually very direct. You will have 1 over 4, okay, and you will have the answer. We integrate it. It's supposed to be ln f. So what is your f? Your f is x squared plus 9 over 4. Okay, let's just look at the second integration. If we look at the second integration, that is same as what we did in the example 1. So in the example 1, we are supposed to have the a squared. So in here, you can change your 9 over 4 in terms of a squared. So your 9 over 4, you can write it as 3 over 2 square, right? So you will have 9, and you have x squared plus 3 over 2 squared. Okay, let me pull out the 9. So you take out the 9, so the 9 will be at the front, so you have 1 here. Okay, so this is actually in terms of this form, right? So you can use this formula, and you know that your answer will be in terms of tangent inverse for that one. Okay, let's continue the next line. So this is already the answer for the ln, so we just copy back, and then okay, and it's 9 over 4, and we'll apply that formula that we will see here. That is this one. So we have this. Okay, we'll apply here. So we have the answer that is in terms of tangent inverse. So you have the tangent, oh sorry, it will be 1 over a first, right? So you have 1 over a, 1 over 3 over 2, and we have the tangent 1 over a is 3 over 2, and tangent inverse 3 over 2, x over 3 over 2, and plus a. Okay, so we simplified this one. So if you simplify this one, then we have the last side of this solution. So you have the 9 over 4, okay, multiply with 1 over 3 over 2, then that is give you 3 over 2. So and the tangent inverse, you will have 2x over 3 plus c. Right? So that is the answer for the example 2. Okay, in this example, so we have 3 items in the quadratic. So we have the x squared, we have the x, and we have the constant. So now we're going to apply this first step, that is completing the square, in order to solve this integration. So let's just go for the first step, like completing the square. So okay, so we have the x squared minus 2x plus 3. So by using completing the square, so you will have the coefficients of the x is actually minus 2, so you will have minus 2 over 2 square minus 2 over 2 square, and then you plus back with the 3. And then for the first one, then we have the x, and negative 2 over 2, that will give you minus 1. How about the back? The back here, so we will have the negative 1 plus 3, that is give you plus 2. So by using the completing the square, so you will have the quadratic in terms of x minus 1 square plus 2x. So now we have done with the completing the square. Now the next step is we're going to do the substitution in order to solve it. So how to do the substitution? The substitution step is actually very direct. So just take whatever that is in terms of the bracket in the bracket to do the substitution. So let's just do substitution. We sub the u as x minus 1, and you have the du that is equal to dx. Right, okay. So let's go for the next line. So you have the, this is 3, and then you have this one is actually your u, and you have the u square plus 2, and the dx is actually equal to your du, right? So you have your du. Now we have something like that. Okay, so the next line, then you will have the 3 at the outside. So we have 1 over u square plus 2 du. And if you look at the form that we have, okay, so basically we'll go for the, you're already in the general form, okay, of the first. So general form of the first of this, general form of the second. The general form of the second, that is the answer should be in terms of the tangent inverse, that is this one. So because you have one there, right? So now so means that you have to figure out what is your a here. So your a here, that is your a square. So your a square in here, that is actually 2 square, right? So this one said you can write it in terms of u square plus 2 square. And this, okay, so by the manipulations, that means that you will have the answer that is in terms of tangent inverse, and you can apply this formula. So you will have 1 over a. So now your a is 2, and then we have the tangent inverse, and this is now we have the x in the formula. We have the x in the formula. But what we have here is we have u. So means that you have to manipulate it a bit. So this is your answer will be in terms of u. So your answer will be in terms of u. We will have u over Z2, right? Okay, and then plus C. Okay, and this is actually 3 over Z2 tangent inverse u over Z2. But don't leave your answer in this way because your question initially is not in term. It's not in term of the u, but it's in term of x. So you have to make sure that your answer is supposed to be ending in term of the x also. So you have to sub the u back. You have to make the substitution back. You have to check back what is your u. So your u is actually x minus 1. So you will do the substitution in here. So we will have the final answer is just in terms of the x only. So your u is actually x minus 1. So we have over Z2 plus C.